All right, we're in chapter 2 now, looking at section 1 on displacement and velocity. And before we can talk about displacement and velocity, we first need to talk about frames of reference. So, what is motion? How can we tell that something is moving? So I have an example for you here, okay? I have a black ball, and I'm going to throw it across the screen. Did you see it? Do you know that I threw a black ball across the screen? Maybe I did nothing. I told you I did it, so did I do it? Okay. So how do we tell if something is moving? What if I now take a red ball and throw it across the screen? Everybody saw that, right? So how did you tell that that was moving? Well, what we need is something to compare the object's motion, the object that is moving with. Okay, so the thing that we compare the object with is called a frame of reference. So a frame of reference can be anything that you compare an object moving with. So for example, it could be other objects. So in the example with the black screen, you didn't know, you couldn't tell anything was moving because the black ball was the same color as the black screen behind it. Whereas when you have this white background that we have, right, they're different colors, okay? Now if it was just plain white and that's the only thing you saw, and you saw the red ball, okay, it might be more difficult to tell if it was moving depending on if you were moving too. But with your computer screen that you're looking at, you can see the edges of the video, you can see these words, and you can compare the motion of my little red ball here with the not motion of the other objects. Okay? So the words on this screen, the edge of your screen, they're all acting like a frame of reference. So really anything can be a frame of reference. It can be any other object. Okay? But it can also be a coordinate axis. So let's look at an example of a coordinate axis. Alright, so a coordinate axis is a graph, and we will use this a lot to show the movement of an object, and we'll always use it in physics when we're describing motion in 1 and 2 dimensions as our frame of reference. So for example, you can imagine you, yourself, as standing at 0, 0, okay? And you take a ball and you kick it. Okay, and you kick it and the ball might fly up into the air and come back down and then bounce. Okay, so this graph now is our frame of reference. We can look at this graph, okay, it's stationary compared to the motion, and we can see the ball fly and bounce around. So we can tell that the ball is moving because we have a frame of reference. Now if you're kicking this ball in real life, think about what your frame of reference might be. How can you tell it's moving? Well, you might be able to tell in real life that it's moving because there might be trees you see, or the ground. Okay, there could be a fence. Any of these things might help you know that the ball is moving. So one thing I want to point out with this, okay, is that motion takes place over time. Things don't move from here to here instantly, okay, right? It had to travel. And on this video screen, right, you may see the point here and then the point here, but I had to move my hand to get it there, okay? So that motion taking place over time depends on our frame of reference, okay? So that helps us see where and how far and how quickly it moves from here to there. But I want to point out something, okay? If the position of an object does not change with respect to a frame of reference, then it is not in motion. So what does that mean? Okay? So to understand this idea, I want you to think about, say you are in a van, okay? So here's our van. And this van has no windows. And you're inside and everything is black, okay? Now, if that van is just driving at a constant velocity, okay, So it's not speeding up, it's not slowing down, it's moving. There's no bumps in the road, okay, and it's dark. Would you know that you're moving? Okay. Well, likely you wouldn't, right? We would need at least bumps in the road or speeding up or slow down for us to tell if we are inside this van. Okay. So, even when you're in a car, think about you throw a ball up and you catch it, and you're not compensating for how fast the car is moving, okay? So, motion depends really on its frame of reference, okay? An even bigger example, okay, is to think about the world, okay? The world is moving around the sun, right? And it's moving really fast, and it's also spinning about its axis, and we are all on it. And for thousands of years, we didn't know that the ground we stand on is moving. Okay? That is what a frame of reference does. It tells us we are moving. And without the knowledge of the frame of reference, we don't know that we're in motion.